I wasn't even that good at maths in the early days either. I was actually recommended to not do A-level maths by some of my teachers there, so yeah, I showed them. Okay, my name is George Brown and I am a structural engineer currently working at Fairhurst. I basically design buildings for a living using quite a lot of mathematics, but also knowledge of the construction industry and how buildings and all the associated materials, wires, pipes and all the rest of it fit together to form a building. So as a kid, I used to play with a lot of Lego, and I used to like computer games that usually involved either building cities or structures and things like that, and lemmings as well, if any of you know that, building bridges to solve problems. And then at school, I gradually got better and better at things like maths, chemistry and physics. Didn't really know much about the construction industry when I was at school, but when I asked my university advisor towards the end of school what they thought I should do, they said, well, based on the fact that you're doing maths, chemistry and physics for A-level, why don't you give engineering a go? And so I did, and here I am 10 years later. So because I went to do it in Scotland, in Edinburgh, the total master's degree length was 5 years. Usually it takes 4 years in the UK. As part of the engineering course that I did, they eventually, towards the end of it, start to request that you do work placements during your summers off, so that you can sort of gain a bit of industry experience and start to work out where all these numbers and equations and essays on very, very technical things actually apply to the real world. And so it was then that I got my first taste of actually working in industry, and my university advisors, they had contacts in industry and they helped me find a placement. Let me think. So when I was doing my GCSEs and A-levels, I worked on the tills at Waitrose. I'm trying to think if that applies at all to what I do now. I suppose there was a bit of numerate stuff, cashing up at the end of the day. I think ultimately all jobs eventually lead you to needing to work as a team with other people. So in that sense, working as a team to keep the shop running, telling the boss about problems that you've seen, yeah, it all applies to what I do now, definitely. So just go and get as much work experience as you can in whatever it can be. So essentially, there are property developers out there who've put together a lot of money and they want a building to be designed by a professional design team and eventually built. So depending on how many projects you're working on, I'm working on about 5 or 6 at the moment, I've just got a set of deadlines. So each of the different projects that I'm working on is at a different stage. One of them I've been given from scratch recently, no design development at all, just literally a few basic drawings of what the architect, they're the people who have the overall building vision, thinks the building's going to look like. So I've taken a look at it, worked through their drawings and started to sort of sketch on where I think the main structural elements will go, the columns, the foundations, as well as the drainage as well. Where does the drainage go? Great big pipes underneath the ground, you need to make sure that there's plenty of room everywhere for them. So when I started off that project, my day involved just looking at drawings and started to sketch ideas. And then later on we had to turn those into professional AutoCAD drawings. So I worked with one of our technicians. We have professional people who can do professional drawings here, that's a key part of the engineering industry. I can do all these lovely sketches and things like that, but when the builder gets them on site, they're not going to be able to build it. So we have to turn them into these big detailed dimension kind of blueprints. A lot of my day-to-day is turning my designs and calculations into those professional drawings, feeding sketches to my technician, who will then use their computer software to draw them, and then I make sure that everything is fitting together and could actually be built by a builder on site. And then when they're building it, I'll often get a phone call from one of the contractors who's building it on site saying, "George, can you come down and have a look where we've just had a go at building something you've designed? Can you come and check that we've done it right?" And fingers crossed, when you turn up on site and you get your hard hat and a high visibility vest on, everything is looking nice. But sometimes you see problems. Maybe something's cracking. Why is it cracking? Maybe there's been a problem in the design. Maybe someone did a calculation incorrectly, or maybe the builders aren't doing things properly. So there's a lot of going to site and doing inspections just to see how things are going on the construction site. So I quite enjoy that aspect of it as well. I'm out of the office probably about a quarter of my time in total. Well, ultimately, I work with a design team. Myself and usually 5 other different professionals in the different areas of the industry, and we all work together, communicate, usually over a period of about a year, and then they start to build what you've designed. So you get to see these great towers that are going to stand there for 50 years, and you had direct participation. So it's really satisfying from that aspect. It can be a stressful job, a lot of responsibility. You need to make sure that you really have an understanding of all of the, not just the sort of the calculations and the science, but some of the legal implications as well of what you're doing. We have to make sure that all of our designs comply with all of the building regulations of the UK, and we always have to submit a lot of information to the local authorities to make sure that they're happy with what we're designing. And then, just seeing it all going together on site, you really need to make sure that what you've done is correct. But with the whole design team and your bosses helping you, checking what you've done, talking ideas through, it's a rare thing that anything ever really goes wrong. I was quite studious, never really sort of naturally that intelligent. I was always in very middle sets, and in the earlier parts of school up until GCSEs and the lower sets, I was a slow starter. I kind of started in the kind of bottom third, and then just slowly worked hard and worked my way through the sets, and got some of the higher sets by the end of it, and I got like 100% on my maths modules for A-levels and stuff like that. But it was an arduous process. Didn't just come naturally at all. And as I said, the whole kind of mathematics thing didn't really click with me until probably around about year 10. And I suddenly kind of got the hang of it. I didn't understand what a graph was. No teacher could tell me what a graph was. Why with some numbers and some equations does a line appear? What does the line tell us? And it took probably until halfway through year 10 for a teacher to kind of just clarify that it was just a representation of how numbers relate to each other. I think that was the kind of eureka moment, and it all fell into place after that. Obviously the first step is to develop your numerate skills. Probably just gaining an awareness of the construction industry. There's a lot of interesting websites like constructioninquirer.com, and actually going and just reading about some of the mega projects that are going on right now I think could be interesting to anyone, not just people who are engineers. Just seeing some of these huge tall towers, you know, like the Burj Khalifa, or some of the great bridges that are being built recently, they're just amazing. So if you sort of wanted to gradually start going in a kind of engineering direction, just find some good websites or magazines that just talk about the great things that are going on in the world at the moment. Just read about them, because ultimately it's steel and concrete and glass just being put together in a building configuration. It's not too hard to understand. And work on those maths. Behind all of it, behind all these big projects and these great towers that you see everywhere, there's actually a team of people who have had to think extremely hard over a year or more. Mathematicians, talented artists who've actually had to draw it and, you know, draw pictures of the building long before it was ever built. So there's a team of very hard-working people making sure that the idea becomes a reality. There are actually people that have done it that way. People who left school at 18 and went straight into sort of lower level engineering jobs. I don't know too much about that, because that was not my route, but there are people here who are doing it. And actually some of those people usually are in a higher position in their job than the ones that go to university, relative to age. I spent 5 years studying. Some people spent 5 years working. So you can imagine that I might have come out with slightly stronger grasp of a deeper, higher mathematics, but I didn't have 5 years in industry experience. And I can tell you right now, the amount that I learned after leaving university totally outstripped everything I learned there. That just kind of prepared me for the levels of learning that I needed to go through once I started working. And actually, a lot of things I learned at university haven't really even been applied in my career. So different and varied is the stuff that I actually have to think about now. So university's just the beginning, that's all I'm saying. Being able to communicate is a key one. If I've sat down and run some analysis, done some calculations, sketched a few things, and I've decided that something isn't going to fit together properly on site. Maybe the crane won't be able to lower this enormous great steel beam into position the way that the contractors are hoping it will. I need to explain to them what the problem is that I foresee, and then also communicate how we're going to start to solve the problem. I can't just highlight problems, I have to provide solutions as well. That's one of the key things about what I do. So being able to sort of do some thinking, realise that there's a problem, know that there's a solution to be found somewhere, and then communicating that to the right people. That's something that's such a key element of what I have to do. Sketching was a big problem. I was rubbish at sketching when I came out of uni. I wish I'd done more of it in my spare time, because I have to, in the middle of a meeting, sometimes in order to, once again, communication. In the middle of a meeting, we might be discussing a problem, and the best way to solve the problem is just to sketch a picture of the thing that you're going to build that might solve this problem. Maybe a new concrete foundation to support a load coming down. Sometimes just to visualise how a problem is going to be solved, just needs a little picture, a little sketch. During your summer holidays, I would really suggest trying to find work placements available in some industries that you've researched, just things that you think might be interesting. See if you can find yourself a month placement or so, or even a few weeks, and it'll just give you a taste of what's really going on out there. School is a place where teachers talk to you about things, and you're around a lot of other kids. The working world is full of trained professionals. There's a lot to find out from them that you never find out in school. So trying to get out into that world a little bit when you're still at school will help you get a flavour of what's really happening and just what types of work are happening out there, and it may give you ideas for the way you really think you'll fit in after university. And then carry it on through, I would say every summer, do some kind of work placement. And, probably after a few years of it, you'll start to maybe realise which kind of industry you might want to get into. Well, in terms of the design team behind the building, there's a whole load of different trades and different people. There are quantity surveyors that we talk to. So I'll design a whole load of steel and concrete elements. I'll size up some foundations to go in the ground, but the cost of that, I'm not dealing with it. Somebody else is having to pay for all that material, and basically we have something called a tender. And basically one of the first kind of hurdles to get over in the design process is for the whole design team to develop their drawings to a point where a quantity surveyor can actually put a price tag on the project. Because if a huge building is going to get built, my goodness, a huge amount of money needs to be found, procured and poured into it. So people are asking me, if I come up with a solution, quantity surveyors want to know how much it's going to cost. What's going to be the weight of steel going into that? Maybe even how long will it take to construct? A group of builders, each one needs to be paid per hour. The costs can really escalate. I mentioned architects earlier. Architects are extremely clever, varied, versatile people. They have a sense, at least, of how structures work, because they have to create this vision of a building. But then they do all this other stuff. The architect has the vision of how people flow through the building, how the building is lit to suit what the people do. It's how the building suits the function of the people who are going to be walking around, living and working in that building. And they really shape how a building project goes, and they know so much about so many different things that the building does. We effectively, the engineers, kind of serve their needs and help them kind of make their dreams a reality. Then there's the client. I talk to property developers, who are the people who are actually financing the project. So whenever we make design decisions, we'll have to explain to them how much things are going to cost, how much time, because it's them that's going to be financing it. And then of course, in an office environment, we have the human resources department. There's always paperwork to fill out at work. So interact with a lot of people who aren't engineers at work, but who kind of keep the office running and keep the fridge stocked with milk, because we need to drink a lot of coffee. And look after us if we have problems at home or something like that and need to book some time off work. Human resources people help us out. Well, in engineering, structural engineering, which is the career I'm going down, the place to start is trying to amass experience in using the sort of majority of the different types of main structural form in the country that you live in. So in the UK, we have brick buildings, which work in one way. We have steel frame buildings, which work in another. Concrete frame buildings, which work once again in their own way. And then there's timber buildings, which we don't actually do that much of in the UK. Whereas if you go to Germany or America, you have these great sprawling, huge timber structures, but yeah, we don't really do any of that. So once you start to sort of master being able to design buildings in each of those three materials, you can start to get to a point where you can work on multiple projects simultaneously. You can help more junior people with performing their calculations or putting together drawings for a whole variety of different types of projects. And then in my case, and actually a lot of people's cases, there are professional qualifications. So in the engineering industry, I'm going for chartership with the Institution of Structural Engineers. Quite a lot of other people are going for a chartership with the Institution of Civil Engineers, which is similar but a little bit different. And basically, you have to sit a gigantic exam to pass it. You basically design 2 buildings in 7 hours. So So luckily I've passed that bit, so I've done that. And then you need to pass an interview. And so basically a professional qualification means that your skills that you developed throughout your career have been put in front and demonstrated to a board of professional people who are experts in the field that you're working towards, and they have deemed you adequate to be trusted at basically the highest level of design. So if you really like the engineering, you want to go for your professional qualifications. So hopefully I'm going to have that by Christmas. It's the sort of thing that you want to be, if you, basically in terms of developing your career, in the engineering industry generally you will hit a kind of a ceiling. You won't get promoted beyond a certain point unless you've got your professional qualification. So yeah, there was studying involved. I had to get clued up on a lot of things that as a more junior engineer I had no appreciation of. So for example, contract law, baffling things for someone who likes to just run their head through numbers all the time. But yeah, learned a lot about all the kind of legal aspects of the engineering industry. Essentially, we have to keep above criminal law. If we don't do our job properly, if we're negligent, it can basically be considered to be criminal offence. So we've got to show due diligence in order to be working within the law. Yeah, I'm working toward the chartership. It has 13 core objectives for the Institution of Structural Engineers. So essentially, I kind of use those 13 objectives as a kind of a syllabus, which I studied my way through and found quite a few things that I sort of wasn't educated in and had to study or talk to my bosses to obtain a great level of knowledge in them. As I said, the contractual and law side of things I literally knew nothing about. As I said before, I wished that school there'd been careers advice at an earlier stage. I discovered the engineering industry about halfway through university pretty much. Even when I was doing an engineering degree, I never sort of necessarily thought about becoming a structural engineer. It just kind of wasn't even on my radar. And I think probably looking around and and having done some work placements or something like that in my kind of GCSE years and A-level years would have really helped me focus and have a better idea of where I was going to end up. So I wish I'd known to do that, but unfortunately I didn't. I spent my summers messing around and being lazy, and I do regret it very much. I dare say if I had done, I might well be further on in my career than what I am now. Although I am doing all right, so it's okay. I would say that the world is a big and varied place, and there's really a huge amount out there waiting for you. The only way to find out is to go and try and get involved with it as much as possible. Unless you go step out the door, do some research, try and get involved in varied things that you wouldn't otherwise get involved in, you're almost closing off your options. If things aren't going to find you, you've got to go and find them. So I would say do your research, kids, and try and find out what's out there, because there's a lot. And the sooner you start looking and thinking about it, the sooner you'll find something and be able to start laying the foundations for as early as possible for whatever it is that you end up doing.